Good morning students. In this video we will discuss transformer, third module of your basic electrical engineering subject. The subject code is 18LE13. So we will discuss introduction part, not in depth. If you want to study depth, we are having third semester transformers and generator subject. You people are computer science engineering students. I am going to ask you a question where we can find transformer in our computer science computer hardware components. Definitely for laptop charging we are having a transformer that inside the charger it converts 230 into 19 volts or 24 volts. Just you have a common sense, right? So the 230 volts is the incoming, but we are converting into 12 volts or 24 volts by using transformer. In that adapter they'll design, transformer, high switching frequency transformers and all, right? And also we can say transformer we're using in the mobile charger, because mobile charger needs only 3 to 4 volts supply, right? So in that charger also we're having a small transformer which converts like 230 to like 3 volts or 4 volts. Even though LED lamps, right? LED lamp inside there is a transformer present, small transformer, because to converting less voltage purpose. Just to dismantle the parts of charger, adapters and LED lamps and also TV adapters. Inside the TV also we are having transformers. The best example another I can give you, like just you find out nearby your surroundings there is a H pole mounted substation or H pole mounted transformer. They will place in the shape of H, right? That transformer which converts 11 kilovolts into 230 volts plus or minus 5% of tolerance, single phase, or 3 phase 440 volts plus or minus 5% of tolerance, right? So before getting into the topic, complete discussion, we must know the definition, right? Transformer is a device which is used to transfer the power from one place to another place or one circuit to another circuit. Name itself indicates. See the title, transformer, transfer the power from one place to another place or one circuit to another circuit. One place to another place, how we can give a example, like unequal to our college, there is 11 kilovolts, right? Just you search near to our college, backside of your college gate, there is a transformer is present. That is cement concrete mounted, not H pole mounted. Usually they will place in the H pole mounted construction. Backside of our gate we are having a step down transformer which converts both 3 phase as well as single phase. 11 kilovolts 3 phase is converted into single phase as well as 3 phase. Next doubt we are having, in our home where we required single phase power supply and 3 phase power supply. Why they are placing the transformer near to our home, right? Single phase power supply required our home appliances, and 3 phase supply for lifting of water, that borewell is there, right? That is 3 phase power supply. You can find there is a red wire, yellow wire, blue wire and one green wire or white wire. That is 3 phase. If it is only phase neutral will be there, only 2 will be there, means definitely that is a single phase, right? So let's see one by one complete discussion. Introduction part. Okay. Transformer, as you can see the diagram, I think nearby your surrounding, same type of transformer they used to keep because of conventional part. Converting the 11 kilovolts into 230 or 415 volts, right? So here there is a input, okay, 3 phase input. These are all the bushings, okay, and here I'll place one transmission lines, okay, disconnected here and disconnected here. I'll just place and this connected here, and one neutral wire will be there. If it is neutral is present, that is star connected. If it is delta, no need of neutral, only 3 wires will be there. Otherwise 4 wires will be there, means definitely that is neutral present. Okay. What about the output? Just you see the diagram. Output here 1, here 1, and here 1, and here 1, right? This I can take R, this I can take Y, this I can take B, and this I will take neutral, right? R wire, red wire, Y wire, yellow wire, B is the blue wire, and is a neutral green wire, okay? That is 3 phase, okay? 3 phase output. This is the input, okay? Input around here 11 kilovolts, 3 phase power supply. And here output is 415 volts, 3 phase, or 230 volts, 3 phase. Okay, anything is possible. Single phase as well as 3 phase. If you connect one B to one neutral, you will get a single phase. Okay, if you connect RYB neutral, you will get 3 phase power supply output. Keep it in your mind. That's why we are using transformer. And here there is a tank. What is the purpose of tank? For filling the oil, right? So there is a reservoir present. If suppose current flowing through this conductor, I mean like wire or transmission lines, there is a here core will be there, windings will be there, right? Later we will discuss in detail why we are filling the oil, and then what is the purpose of a core, and then what is the purpose of windings. If suppose the current is flowing through the winding, what happens? It produces some amount of heat, right? When heats appear in the oil gets evaporates, right? For that purpose we are having a tank for filling of that oil. Only 80% of oil is filled with the transformer tank. Why not 100% of oil is filled with the tank? For example, I can say in our home there is a pressure cooker present, right? For cooking the rice. If you fill total amount of water, what happens? It will blast. I mean, it will not give a visual sound also. Only the certain amount of water we have to fill, right? Similarly here also, if suppose if you fill full of oil inside the transformer tank, sometimes it may get blast because there is no vapor place for the vapor, right? And also it will produce some amount of gas also. And these fins will be there, right? This number of fins, thermal fins, right? For cooling purpose or circulating the oil purpose. If suppose current is flowing through the conductor, heats get produced, right? So it will be in the top. So again that recycling for maintaining the uniform cooling. So we are having fins over here, and here there is a Buchholz relay for cooling purpose. For the safety purpose. Buchholz relay or Buchholz relay for safety. If suppose transformer oil consisting of dust particles, moisture contents, what happens to the transformer? There is a tackle sound, there is a lashes. So that's why we are having a Buchholz relay for rectifying the transformer oil conditions, or if suppose anything fault occurs, if suppose transformer windings may get damaged, that will detect by Buchholz relay. Okay, this is a transformer part, and here there is a mounting rods. Right, this is a transformer. Input is this part, output is this part. Okay, I'll show you one picture from Google I have taken. Okay, see here there is a application of transformer. This is a step down transformer. I have taken photo of, from Google, but you can find this type of transformer near to your home. There is an input. This is the input. Okay, this is input, and this part only one wire is going here, right? It is having 4 wires, R, Y, B neutral. That is output. Here input is 11 kilovolts, and what about the output? Output is 440 or 415 3 phase, or 230 plus or minus 5% of tolerance single phase, because we need single phase as well as 3 phase, right? So this is the complete diagram. Okay. You can see the detail or cushion board or nameplate details near to your home. There is a cushion board, there is a skull board, danger area, the conversion is 11 kilovolts into 415 or 230 volts power supply. Likewise, they used to mention because there is a conversion part, heat appear in the transformer, so they'll place that cushion board, right? This is for distribution purpose, one application I can say. And internal part of transformer over here, again I'm going to draw one diagram. Here there is an input terminal, okay? This is input. This is single phase transformer. In our syllabus only single phase transformer will be there, not three phase transformer. Three phase transformer having 3 windings, but single phase transformer only 2 windings, right? So this is input 11 kilovolts, and this is output, okay? This is output. You can take here 11 kilovolts, other it may be 230 volts, okay, fine. You can take here any voltage, 230 volts to 240 volts based on the transformer winding, okay? If it is transformer windings in the secondary less, definitely that is a step down transformer, right? So internal cross section we are going to discuss now. So here till here oil is filled 80%, and this is a thermal fins for circulating the oil purpose or cooling purpose. So when current is flowing through the transformer winding, what happens? Heat is appear right at the top. So again it will be recycling over here, like recycling in the sense cycle like this. It will be form like a uniform cooling. And next we have Buchholz relay. If suppose moisture contents or any other dust particles, if suppose transformer windings may get a spark or whatever, if fault appears, definitely it will be like detecting that fault and send the signal to the circuit breaker, and then transformer, the more damage can be avoided by using Buchholz relay, okay? And next there is a breather. Breather is for to sucking the moisture contents, dust particles inside the transformer tank, oil, okay? And oil level conservator for filling the oil. If suppose evaporation occurs, if suppose current is flowing through the conductor, heat appears, so the oil level will be decreases, and tank is for filling that oil. This is a constructional part of internal cross section of transformer, okay? Thank you. Next we'll discuss working of transformer and types of transformers. Thank you.